Hello students, this video is for grade 9th, day 16, chapter 2, polynomial. In this video, we are going to solve question based on factorization using identities for cubic polynomial. Before I start that particular topic, here I'll be solving few doubt questions asked by students. Now these questions are from chapter number 1, exponent topic. These questions I have given you as an assignment as well. The first question is that simplify x to the power 1 by 2 into x to the power minus 5 by 4 divided by x to the power 3 by 4 whole to the power 4 by 3. As they are in the product form, so definitely we'll add the power, and this is at the denominator, so definitely we'll subtract the same power. So on simplification, we'll get 4 as the LCM. Here it will be 2 minus 5 minus 3 and whole to the power 4 by 3. On simplifying this, I'll get minus 6 by 4 into, as we know, using this exponent, whenever you solve a question based on exponent, please write the particular identity whichever you are using. For example, here I am using x to the power a to the power b, so it should be x to the power ab. So I'll write here x to the power, these power will be in the multiplication form. So if I'll simplify it further, then I'll get x to the power minus 2, which is the reciprocal. So I can write 1 by x square. The next question is x to the power 4 by 3 into x to the power minus 1 by 2 into y to the power 9 by 5 whole to the power 3 by 4. Here, first, if I remove this power, then definitely this will be multiplied by the power of x and also with the power of y, right? So x to the power 4 by 3 as it is, into x to the power minus 1 by 2 into 3 by 4 into y to the power 9 by 5 into 3 by 4. Now if we multiply this numerator, denominator, because we cannot cancel any number, so I'll get 9 3s are 27 into by 20, 5 4s are 20. Into, similarly in case of x, here we'll get minus 3 by 8. And whole is getting multiplied by x to the power 4 by 3. If I remove this bracket, then definitely this x will be multiplied by this, and we'll get x to the power 4 by 3 plus minus 3 by 8, because in that case the power, in case of multiplication, we add the power. So here we are adding it, and it will be multiplied only once, because 3 into 4 into 5 is 3 into 4 into 5. We don't multiply 3 two times. So it will be like that, and y to the power 27 by 20 will leave as it is. On further simplification, if we take 24 as the LCM, we'll get 32 minus 9, which is 23 by 24 into y to the power 27 by 20. This is the answer. The next question is 4x square into 6x cube. Here we'll multiply the number, that is 6 4s are 24, and the power of x we'll add. So x to the power 3 plus 2, which is 24 into x to the power 5. The next question is 49 whole to the power minus 3 by 2. So 49 can be written as 7 square into minus 3 by 2. So this 2 and 2 will cancel out. So we'll get 7 to the power minus 3. Now this 3 in the reciprocal form, we can write 1 by 7 to the power 3. So 7 to the power 3 is 343. So I can write 1 by 343 as a final answer after simplification. And the last question is 343 x to the power 6 whole to the power 1 by 3. This is the last question. Now 343 can be written as 7 to the power 3 into x to the power 6 whole to the power 1 by 3. If we'll remove this bracket, then definitely this power is going to multiply by the power of 7 and also with the power of x. So 7 into 3 into 1 by 3 and x to the power 6 into 1 by 3. So this 3 will cancel out. I'll get 7, and here 3 2s are 6, so x square. So the answer is 7x square. Now let's start with today's topic, which is factorization using identities. In the last video, I proved this identity that x cube plus y cube plus z cube minus 3xyz equals to x plus y plus z into x squared plus y squared plus z squared minus xy minus yz minus zx. So using this identity, we are going to solve question. We are going to factorize the given polynomial. Now, the first question is factorize a cube minus b cube plus 1 plus 3ab. If I compare this with this identity, it is very clear that at place of x I have a, at place of y I have minus b, and at place of z I have 1. 1 can be written as 1 cube. At place of minus 3 I'll write minus 3, into at place of a I'll write a only, into at place of y, as my y is minus b, so I'll write minus b, into z. Z is what? 1, so I'll write 1. So if you solve this, minus 3 into a into minus b, it is plus 3ab, which is already given in the question. So I have just written it in the factors form. So plus 3ab can be written as minus 3 into a into minus b into 1. Why we are doing this? So that we can use the given identity to factorize the given polynomial. That's why I have written it like this. Now, as we know that the formula for this is what? X plus y plus z. So at place of x I have a, at place of y I have minus b, at place of z I have 1. So x plus y plus z, then x squared plus y squared plus z squared. So a squared minus b squared plus 1 squared minus x into y. So x is equal to a, y is minus b. So minus a into minus b, then minus b into 1, that is yz, then minus zx. Z is 1, x is a. So if I'll solve this, this will be a, plus minus is minus, this is 1, and this is a square plus b square plus 1. Then minus minus is what? Plus ab. Then this minus and minus is what? Plus b, and this minus a. So if I rearrange it, I can write it like a minus b plus 1, a squared plus b squared, this minus a plus ab plus b plus 1. So this is my final answer. Let's solve another question based on the same identity. That is, here it is given that if a plus b plus c is equals to 5 and AB plus BC plus CA is equals to 10, then I have to prove that A cube plus B cube plus C cube minus 3ABC equals to minus 25. Now, first of all, let's write the formula first. We know that A cube plus B cube plus C cube minus 3ABC is what? A plus B plus C, A square plus B square plus C square minus AB minus BC minus CA. You need to remember this formula. This formula is very important from factorization topic. Either the direct proof or definitely the question based on that, there are chances to come in the exam. So this formula is very, very important. You need to remember this. Now, this is the value of this formula. Now at place of a plus b plus c, according to the question, can I write 5? Because a plus b plus c is what? 5. So I'll just replace this with 5. Rest everything I'll write as it is. Alright. Now here we have a square plus b square plus c square. But the value I have is ab plus bc plus ca. So I'll use another identity, that is a plus b plus c whole square equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. This is the formula for a plus b plus c whole square. So using this formula, can I say that a square plus b square plus c square is what? This entire a plus b plus c whole square minus this 2a minus 2b minus 2ca, right? Because I'll be shifting all these terms to the LHS side. So that will give the value of a square plus b square plus c square, right? So I have done exactly the same. What I did here is that since a square plus b square plus c square is this much, I have shifted that. So I can say that the given question is 5 a square plus b square plus c square minus ab minus bc minus ca. So at place of this, I can replace this by the entire equation, right? So at place of this, I can write a plus b plus c whole square minus 2ab minus 2bc minus 2ca. And the rest minus ab minus bc minus ca, I have written as it is. Only I have replaced these terms by this. So if I solve further, I'll get a plus b plus c whole square, and this minus 2ab and minus ab will become minus 3ab similarly. So what I did, 3 I have taken common out. So inside the bracket, the left out terms are ab plus bc plus c. Now according to the question, the value of a plus b plus c is already given that it is 5, and the value of ab plus bc plus ca is already given 10. So I have just replaced it by 10 and I have replaced it by 5. On further simplification, if you simplify it further, I'll get minus 25, which I have to prove. So the value of aq plus bq plus cq minus 3abc is minus 25. Still you have doubt at any of the point, then you can write your doubt in the chat box, in the comment box. Let's solve more question. Find the value of x cube minus 8y cube minus 36xy minus 212 when x equals to 2y plus 6. It is given that x equals to 2y 6. Well, I'll put the value of x equals to 2y plus 6 later on. Let's understand whether I can fit the given polynomial on the identity, on the cubic identity or not. So I can write x cube as x cube, which is my a, minus 8y cube can be written as minus 2y whole cube, that is b. So the value of b is minus 2y cube, and just 216 can be written as minus 6 whole cube. And further, a cube minus b cube minus c cube, a cube plus b cube plus c cube minus 3 into a into b into c, right? So at place of a, what I have x, at place of b, what I have minus 2y, at place of c, what I have minus 6. So if you multiply, see whether are you getting minus 36xy or not. Let's talk about first sign. First, minus minus plus, plus into minus minus. So minus is there, 6 2s are 12, 12 3s are 36, 36 is there, x into y. So when we multiply this, actually we are getting whatever is given in the question, that is minus 36xy. Thus we can definitely factorize this on this formula, right? So I can factorize it. So what is the value? So a cube plus b cube plus c cube minus 3abc is a plus b plus c, a square plus b square plus c square minus ab minus bc minus ca. This is my formula. Now in the question, the value of a is x, the value of b is minus 2y, and the value of c is minus 6. So I'll just replace a, b, c by these numbers, and I'll get the solution. So I have used the same formula by replacing a by x, b by minus 2y, and c by minus 6. And I have written this. So once I'll simplify it, then I'll get x minus 2y minus 6, x square plus 4y square plus 36 plus 2xy minus 12y plus 6. Now the value of x is how much? 2y plus 6. So at place of x, I'll write 2y plus 6, and the rest terms are as it is. Here I can see that 2y will cancel out, 6 will cancel out. So actually we are getting 0. So 0, I'll not simplify it further, because if we multiply any number by 0, the result is what? 0. So the value of this is 0. The next question is, simplify a square minus b square whole cube plus b square minus c square whole cube plus c square minus a square whole cube divided by a minus b whole cube plus b minus c whole cube plus c minus a whole cube. Now as I can see that here a square minus b square can be factorized as a plus b into a minus b, but that will not do. First let's try to figure it out, that whether I can put it on the formula x cube plus y cube plus z cube minus 3xyz or not, right? So suppose if x square minus b square is x, b square minus c square is y, and c square minus a square is z. I have assumed. right? So the value of x plus y plus z is how much? The value of x plus y plus z is a square minus b square plus b square minus c square plus c square minus a square. All the terms are like terms, and with opposite sides it will cancel out. So I am getting 0. So we know that if x plus y plus z is 0, then x cube plus y cube plus z cube is how much? 3xyz. This is the identity. So at place of x, what I have, a square minus b square. At place of y, what I have, b square minus c square. At place of z, what I have, c square minus a square. So I can write the value of this, the numerator part is 3 into x into y into z. This is my question number 1. Similarly, I can consider this a minus b, which is the denominator, which is at the denominator. I can consider this as x, b minus c as y, and c minus a as z. Now, if I add x plus y plus z, again, I'll get 0. So, if x plus y plus z is 0, then x cube plus y cube plus z cube is how much? 3xyz. Therefore, the value of a minus b whole cube plus b minus c whole cube plus c minus a whole cube is 3, a minus b, b minus c, and c minus a. Right? This is my equation number 2. Now, I have the value for the numerator, I have the value for the denominator. So, with the help of equation 1 and 2, I'll just replace this with this one, and I'll replace this with this one, whatever value we have got. So doing exactly the same, I can write as this equals to this and this equals to this. So 3 will cancel out. Now further, a square minus b square can be written as, a square minus b square can be written as a plus b into a minus b, b square minus c square can be written as b plus c into b minus c, and c square minus a square can be written as c plus a into c minus a. So this will cancel out. We can cancel from the denominator part these terms. So what is the left out term? These are the left out terms, a plus b, b plus c, c plus a, which is the required answer. So based on today's class, I am giving you few questions as an assignment to solve. You need to solve these questions. And further, if you find any difficulties while solving the question, then you can write it in the comment box, or you can ask in the doubt class also. You can download the notes link in notes from the link given in the description box, and subscribe the channel for the latest update. Take care and stay safe.